Hello everyone. In this video we are going to discuss about chemical engineering GATE 2020 chemical reaction engineering questions with solution. GATE 2020 question paper and answer key link is available in my description box. You can download it. Question number 21. An irreversible gas phase reaction 2P gives 4Q plus R is conducted in an isothermal and isobaric batch reactor. Reaction is a irreversible gas phase reaction. Condition: constant temperature, constant pressure batch reactor. Assume ideal gas behavior. This is assumption. Feed is on equimolar mixture of the reactant P and on inert gas. 50% of reactant P, 50% of inert gas. After complete conversion of P, the fractional change in volume is. Objective of this problem to determine the fractional change in volume, that is epsilon. After calculating the epsilon value, we have to round off the result to 2 decimal places. Data: given equation 2P gives 4Q plus R. Condition: constant temperature and pressure batch reactor. Feed is equimolar mixture of reactant P and inert gas. 50% P and 50% inert gas. Objective of this problem to determine the fractional change in volume. It is designated as epsilon A or epsilon. Solution part: 2P gives 4Q plus R. This is given equation. In reactant side, 2 moles of P is present. Product side, 4 moles of Q and 1 moles of R. Totally 5 moles are present. In feed condition, mixture of reactant P and inert gas. 50% P and 50% inert gas. This is equimolar mixture. So YP is the feed composition, 50%, 0.5. So our objective to determine the fractional change in volume, that is epsilon A. Epsilon A is equal to stoichiometry of product minus stoichiometry of reactant divided by stoichiometry of reactant into YP. Stoichiometry of product. So refer the equation. 2 moles of P is present in reactant side. 5 moles of component present in product side. So out of these, 4 moles of Q, 1 moles of R. Stoichiometry of product means 4 moles of Q and 1 moles of R, totally 5 moles. Stoichiometry of reactant. So as per the given equation, 2 moles of P is present in reactant side. So that's why we should take stoichiometry of reactant is equal to 2 moles. So divided by same thing, stoichiometry of reactant, that is 2. YP is nothing but, so the composition of P in feed side, so that is 50% or 0.5. So 4 plus 1, that is 5 moles are present in product side, 2 moles are present in stoichiometry of reactant. So then stoichiometry of reactant is equal to 2, YP is a 0.5. Substitute all the values in this expression to determine the fractional change in volume epsilon A. So that is 0.75. So answer for this problem, epsilon A is equal to 0.75. Answer range is given 0.74 to 0.76. So our answer within this range. Okay, so our answer is a 0.75. so our answer within this range. Okay, next question number 24. The decomposition of acetaldehyde, this is X, to methane and carbon monoxide follows 4-step free radical mechanism. This is the decomposition of acetaldehyde to methane and carbon monoxide. Overall rate of decomposition of acetaldehyde or X is minus Rx is equal to K2 into K1 by 2K3 power 1 by 2 Cx power 3 by 2 is equal to K overall Cx power 3 by 2. Here minus Rx is nothing but overall rate of decomposition of X. K1, K2, K3 denote the rate constant of the elementary steps with the corresponding activation energies. So activation energy means this is E1 in kilojoule per mole 320. So E2 40 kilojoule per mole and E3 0 kilojoule per mole respectively. The temperature dependency of the rate constant is described by Arrhenius equation. Okay, K is equal to K naught into E power minus E by RT. Cx is nothing but concentration of acetaldehyde or concentration of X. The rate constant for the overall reaction is K overall. The activation energy for the overall reaction in kilojoule per mole. So objective of this problem to determine the E overall. This is activation energy. So the overall reaction activation energy. This is overall in kilojoule per mole. After calculating the E overall value, we have to round up the result to nearest integer. Okay. Data. Minus Rx is equal to here K2 into K1 by 2K3 power 1 by 2 Cx power 3 by 2 is equal to K overall Cx power 3 by 2. This is a given equation. So in this equation minus Rx is the rate of decomposition of acetaldehyde. K1, K2, K3 is a rate constant. Cx is a concentration of X or acetaldehyde. K overall is a overall reaction rate constant. E1, E2, E3 is are given. The corresponding activation energy value. Cx already I said concentration of acetaldehyde or X. Minus Rx already I said overall rate of decomposition of acetaldehyde or X. K overall rate constant for the overall reaction. So objective of this problem to determine the overall activation energy in kilojoule per mole. This is our objective. Solution part. So in question itself they have mentioned use Arrhenius equation. K is equal to K naught into E power minus E by RT. So here this is K is the rate constant, K naught is the frequency factor, E is the activation energy, R is the rate, this is a gas constant, T is the temperature. So For steps 1, k1 is equal to k1 dash e power minus e1 by rt. K1 dash is this is also the frequency factor. Then k2 is equal to k2 dash into e power minus e2 by rt. K3 is equal to k3 dash into e power minus e3 by rt. So here k overall from this expression, check this equation here. This is k2 na, k2 into k1 by 2 k3 power 1 by 2 up to this. This is k overall. Check this expression. This is k overall. Rest of this cx power 3 by 2. So here k overall is equal to k2 into k1 by 2 k3 power 1 by 2. Take this expression from given expression. Here what is a k2? K2 is given here. This is a expression na. So this is k2 dash into e power minus e2 by rt. Similarly k1 and k3. K1 is a k1 dash into e power minus e1 by rt. K3 is a 2 into k3 dash into e power minus e3 by rt power 1 by 2. So here k2 dash then k1 dash power 1 by 2 divided by 2 k3 dash power 1 by 2. Take this outside. So the k2 dash into k1 dash divided by 2 k3 dash power 1 by 2. This is one side, rate constant. Then here activation energy e power minus e1 by rt power 1 by 2 na. This is can be written as e power minus e1 by rt divided by e power minus e3 by rt power 1 by 2. This term. So the outside term e power minus e2 by rt. So what do you do here? So e power minus e1 by rt can be written as e power minus e1 by 2 rt. So here e power minus e3 by 2 rt. So this minus e3 comes to numerator side plus e3 by 2 rt. So here e power minus e1, okay, e1 by 2 rt. This is numerator, okay. Then denominator term, here minus is there, come to this side, plus e3 divided by 2 rt. This is numerator part. Then one term is there, e2. This is minus e2 by rt. So this term minus e1 by 2 rt plus e3 by 2 rt minus e2 by rt. Okay. So the outside term k2 dash into k1 dash divided by 2 k3 dash power 1 by 2. Okay. Yeah. So already I say. So this is one side, this is another side. Okay. Check the previous slide. E power minus e1 by 2 rt plus e3 by 2 rt minus e2 by rt. So this is. So the common term is rt, 1 by rt. Take outside. So here the same term, we should take k2 dash into k1 dash divided by 2 k3 dash power 1 by 2. So here e power minus 1 by rt, take outside. What is the rest of the term here? e1 by 2, this is plus. Here minus e3 by 2 plus e2. Okay. So this term now, this is activation energy, e1, e2, e3. So this is called as a overall reaction activation energy. So here E overall is equal to E1 by 2 minus E3 by 2 plus E2. So here E1, E2, E3 values are known. E1 value is 320, E2 value 40, E3 value 0. Substitute all this value here. So E1 by 2 minus E3 by 2 can be written as E1 minus E3 by 2 plus E2. Substitute all the values here. This is known value or given value. So find out the E overall. E overall is equal to 200 kilojoule per mole. Answer for this problem is 200 kilojoule per mole. Answer range is given. So the answer range is 199 to 201. So here this is the answer range, 199 to 201. Our answer is 200 kilojoule per mole. Our answer is within this range. Okay. For further related videos, you can like, share and subscribe my channel. Thank you.